Hi students, so this is going to be another video on how to solve trig equations if you need more practice, because the ones that were given before were pretty standard and not that challenging to solve. So we'll get a little bit more into the more challenging ones. So you have four ways you can solve. You can either straight solve, um, that's kind of lackluster there. But what that means is, it's just pretty basic to solve, kind of like the ones that you had in your previous videos. We might have to factor. We might have to pull in some identities into that. So what that means is we talked about sine squared plus cosine squared equals 1, that identity. And that's always true no matter what theta is from Pythagorean theorem. Or maybe we rely on Desmos. So to go to example 1, we're going to solve cosine of 2 theta equals 1/2. Now for your homework and for your exams or quizzes, you will be given a window, so you don't have to worry about adding that to k pi where k is an integer and you're telling the reader that, this goes on forever and ever because this is a non-ending function. But we're just going to focus our attention on one full period. Now, saying that, if we look here, bringing back our knowledge from chapter 5, it looks like we're doubling our frequency. So we need to go ahead and figure out our period for this function. So if you remember, we take 2 pi and we divide it by whatever is inside those parentheses, or attached to the theta, or your input, I should say. So what this means is, if I think about cosine equaling 1/2, just cosine of theta, that happens twice on my unit circle, and I'm only going around my unit circle once. But because I have doubled the frequency, that means I should have 4 solutions instead of 2. So it's a nice way to check to make sure you got all your solutions. So I'm going to go ahead and compose both sides with the inverse. And just like Wendy said, don't do the inverse with the 1/2 in front because that doesn't make any sense. You have to have inverse of cosine of 1/2. You have to have an input. So that leaves us with just the input on the left side. And then I'm going to go to that wonderful unit circle. And it looks like the first place I hit 1/2 for cosine is pi over 3. And the other place I hit it, I keep going around that unit circle, looks like it's 5 pi over 3. Well, I divide by 2, so I get theta is pi over 6. And that's because that's the same thing as multiplying by the reciprocal. So you multiply pi over 3 times 1/2. I'll show it over here in case that lost you. So I have 5 pi over 3 times 1/2. So I get 5 pi over 6. Now, those are 2 solutions. But again, this wave is happening twice within this window. So what I like to do now is get a common denominator. So this is 6 pi over 6, which is the same thing as pi, because then I can add my period to it easily. You know what? This is important. I should just actually set up a new equation so it's not confusing. So I have this solution plus my period, and then I have this solution plus my period. So it looks like my solutions are, and you should write them in order, pi over 6, 5 pi over 6. Then I'm looking here, that would give me 7 pi over 6. And I'm looking here, and that will give me 11 pi over 6. Now I know I stopped there because 12 pi over 6 would be 2 pi, and I want everything strictly less than 2 pi. So again, these solutions continue, but we're just looking in this window, so that's why I know I can stop. It's really important because you're going into calculus that you use set notation. So it's either this or theta such that theta equals. These are your two options. Okay, so going to the next example. Now we're working with tangent, okay? And again, the very first thing I'm going to do is figure out my period for this function. Now, remember tangent, we didn't have to graph it, lucky us, but our period for tangent is actually pi. And I divide it by whatever your input's being multiplied by, so it's pi over 3. So I'm going to go ahead and start solving this. I subtract the 1. Divide by root 3. Now, this looks not like how we usually work with it, so you have to rationalize it. So we end up getting negative root 3 over 3. Okay, now, tangent isn't clear on your unit circle unless you created a little cheat sheet for yourself. But tangent is negative in the second and fourth quadrant. And remember, tangent is sine divided by cosine. So it looks like the first place, let me do arc tangent on both sides actually. I jumped the gun there. Oh, forgive me. Let's get rid of that gun. So I'm left with just 3 theta. So the first place, it's negative root 3 over 3 is 5 pi over 6. And the second place would have to be in the fourth quadrant, and sine divided by cosine is going to be 11 pi over 6. If you divide by 3, which is the same thing as multiplying by 1/3, you get 5 pi over 18. Okay, now, this is interesting. We got 2 solutions, right? But we are going through this guy 3 times as fast, right? So that means I should really have these 2 solutions times 3, so I should have 6 solutions total at the end of this. Now, in order for me to add my period to the 2 solutions I have, I need to find a common denominator. So my denominator here is 18. So that's why I'm going to multiply this thing by 6 over 6, because I get 6 pi over 18. Okay, so now I have theta equals 5 pi over 18 plus the period. So I get 11 pi over 18. And then this one, which, bummer, I already had that, right? Like, we already had that here. It just gave me the same one. Then I have 11 pi over 18 plus 6 pi over 18. And so I get 17 pi over 18. Now, I have to keep going until I get close to 2 pi. So we're just going to do this verbally. My first solution was 5 pi over 18. Second solution, I got 11 pi over 18. Now just think about this. We're just going to keep adding this period to these solutions. So 11 pi over 18 plus 6 pi over 18 we did down here. So we got 17 pi over 18. If I add 6 pi to 17 pi, I get 23 pi over 18. If I add 6 pi to that again, I get 29 pi over 18. So far I have 1, 2, 3, 4, 5. I need one more solution. And then I get 35 pi over 18. Now I know to stop there, excuse me, because 2 pi, a little side note right here, is equal to 36 pi over 18. So 35 pi over 18 is just a little short of that, so we're good. All right, so moving on. Here's another one. I don't have to do anything on the, like to isolate cosine, my trig function, because it's already isolated. I should still figure out my period. It's just a good habit to get into. Nothing is being multiplied by that theta, so my period remains 2 pi. So that means because we stop at 2 pi, we're not going to have to add anything to this. So I'm going to compose both sides with the inverse. So I get theta minus pi over 4 equals, so where does cosine equal 1? It actually happens 2 places, right? 0, or you go around the unit circle another time and it's 2 pi. But if you see here, this does not include 2 pi, so that's why I'm forced to choose 0. And then I add pi over 4. And this was a nice one, it's just pi over 4. Now, maybe you're like, no, I want to add 2 pi. But again, if you add 2 pi to pi over 4, you're bigger than what you want. So my answer is pi over 4. All right. Now this beauty. You have something that's squared and something that's not. And they're the same term. So we're going to go back to our algebra days. And when we have something squared, and then we have the same term that's not squared, my mind thinks I have to factor this. So I'm going to just, this is a side note. I'm going to look at this as like 2x squared minus x minus 1 equals 0. And you have to think, okay, what are your factors? All of us were taught so differently with factoring. So if this was not how you were taught, bear with me. You can use however you were taught. But the AC method is known as you multiply 2 times 1, you multiply the A times the C, and you list the factors. Which ones subtract to the middle term, which is -1. So those are those. So I get 2x squared minus 2x plus 1x minus 1. So I didn't change the problem at all because -2x plus x gives me a -x. So now you group the first two and the last two. Again, this is the AC method, so if this isn't familiar to you, we end up getting 2x is the GCF for those two, so I get x minus 1. And this one doesn't have 1, so you take out a 1. And when these are the same, that's one factor. And then the outside guys are the other factor. Some of you might have just jumped from here to here, which is great. Or the box method, there's a bunch of different ways. Well, this is very similar to this one, except your cosine now is just x. So I'm going to rewrite it the long way just so it makes sense. 2 cosine squared theta. We said it would be minus 2 cosine theta plus cosine theta minus 1. If I group these two and then these two, I can take out a 2 cosine theta. I'm left with cosine theta minus 1. plus nothing is in common with those, so I take out a 1. And we end up getting similar factors, just our variables are different, and our functions are different. And so what do you have when you have two things multiplied and they equal 0? Well, that means one has to be 0, or the other one has to be 0. So I solve, I'm going to add that 1, compose both sides. Where does theta equal 1 on cosine? Well, again, you have to look here. And I'm going to choose 0, not 2 pi. And then here, just to save me a little time, I get cosine theta equals -1/2. So I compose both sides. Where does cosine theta equal 1/2? So that's pi over 3, and then 5 pi over 3. So we want to go ahead and list these in order. I do not have to worry about finding any more because the more I find, they will be outside the window that I'm looking at. So for example 8, I'm just looking how much longer we have because I'm over my limit, my time limit I promised you. So example 8, the difference is here, we do not have the same terms. So we have sine squared and sine, and then we have cosine squared. So what we need to do here is get them to be like terms. And because this one is not squared, that sine, that's my indicator that I'll change this thing to be sine. And what I mean by that is we know this to always be true. So what I can do is I can solve for cosine. So what I now know is if this is true, I can replace this. So I have sine squared theta minus sine theta equals, I'm going to replace cosine theta now with 1 minus sine theta, so sine squared. I'm going to get this to equal 0. So if I take over my sine squared, take over that 1, I end up getting 2 sine squared theta minus sine theta minus 1. And this looks pretty darn similar to the one we just factored. It was just cosines in that example. So I'm going to jump the gun and factor this the same way. Or maybe you want to pause the video and see if you can factor it on your own. It was 2, and then we have a sine theta, and this is a 1, and this is a 1. But I want it to be negative in the middle. So if I set both of these equal to 0, save some time, I end up getting sine theta equals -1/2, and over here I get sine theta equals 1. Where does theta for sine produce -1/2? So for sine, it looks like we'll be in the 3rd and 4th quadrant. So it looks like the first place is 7 pi over 6, and the next place is 11 pi over 6. And then here, where does sine produce 1? That's pi over 2. So again, let's put these in order. Looks like I hit pi over 2 first, then I hit 7 pi over 6, then I hit 11 pi over 6. Okay, so what I would like you guys to do actually is try these next two on your own, just using Desmos. And example 10, you have options, because this would be on your calculator portion, something like this. Try doing it by hand and then compare it to using Desmos. And what we'll do is next class, we'll start with these two examples. Okay, bye-bye.